Hi guys, let's discuss about relation between initial speed and angle of flight effect on distance travel. Objective: to discuss the factor affecting based on the angle of launch and the initial speed.
So now we are in the projectile motion effect. As you can see, there is intro, vectors, track, and lab. And make sure you choose the lab simulation in this part to run this experiment. Okay, now we will run the experiment as in a procedure, which is the part A, effect of the angle of launch to its range. First, choose the interface of projectile motion in lab simulation. And from the fact interface, set the material to a cannonball. As you can see, there is a box there, and make sure you choose it to a cannonball. Next, with the mass of 15.5 kg, 0.18 meter per diameter, gravity 9.81 meter per second square, and you should not take the air resistance because this experiment is without air resistance. Next, the initial speed with 15 meter per second. Set the angle to 25 degree. And as you can see, there is a normal and slow. So I will choose it to be a normal fire because you can see how the cannon be fired. And then you will enter the red box, which is the fire. Yes, that is how the cannonball be fired. As you can see, now the cannonball is being fired. So take the point and measure to the last part of the cannonball fired. As you can see, the dot is light up, so it was the accurate one. So you will see the time, range, and height, and record this value of each range to your table, so we can discuss it. Okay, then we will increase the angle of launch to 35 degree, 45 degree, 55 degree, and 65 degree. Okay, now we will run the experiment in the part B, which is the effect of the initial speed of launch to its range. Repeat the step 1 to 2 in the part A. As in the last part, it was the same except the initial speed, because it was the effect of the initial speed, so this is different of initial speed. So set it to 11 meter per second. So we will also set the angle of the cannonball to 45 degree. We must fix that angle so we can know the effect. Okay, now then we can fire the cannonball. Okay, now we will measure it. Like the last part, go to the last part of the cannonball fire, and we will see time, range, and height. So record it to your table. And you will proceed this part B with different initial speed and record it to your table.
Next, we will discuss about the results. For part A, which is about the effect of the angle of launch to its range, we will observe the change of range due to different angle of launch. When the angle of launch is 25 degree, we get the range 17.57 meter. When the angle is 35 degree, we get the range 21.55 meter. When the angle of launch is 45 degree, we get the range 22.94 meter. When the angle is 55 degree, we get the range 21.55 meter. And when the angle is 65 degree, we get the range 17.57 meter. Here we can see that as the angle of launch is increased, the range is observed to increase as well. However, after 45 degree, the range getting smaller. So the maximum range is reached at 45 degree. So here we can say that range is directly proportional to angle of launch only up to 45 degree, and then inversely proportional up to 90 degrees. For part B, which is about the effect of the initial speed of launch to its range, we will observe the change of range due to different initial speeds of launch. When the initial speed is 10 meter per second, we get the range 10.19 meter. When the initial speed is 11 meter per second, we get the range 12.33 meter. When the initial speed is 12 meter per second, we get the range is 14.68 meter. When the initial speed is 13 meter per second, we get the range 17.23 meter. And when the initial speed is 14 meter per second, we get the range is 19.98 meter. Here we can say that as the initial speed is increased, the range is observed to increase as well. So we can say that the range is directly proportional to the initial speed.
Firstly, we will discuss effect of the angle of launch to its range. Using linear motion equation, they are divided into horizontal component and vertical component. Range of object travel horizontal component can be calculated by multiplying initial speed horizontal component with time of flight on air, such as Sx equal v cos theta t. Other than that, we also can calculate the maximum range r by squaring the initial velocity, multiplying with sin 2 theta divided with gravity 9.8 squared using this formula, r equal v2 sin 2 theta over g. In this experiment, the initial velocity of cannonball is fixed to 15 meter per second, while gravity is fixed to 9.8 meter second squared. The angle of launch is set to 25 degree, 35 degree, 45 degree, 55 degree, and 65 degree. At some angle, the distance cannonball travel will be the same. Take a look at angle 25 degree and 65 degree. They have a same distance travel which 17.35 meter. The distance of cannonball travel at 35 degree and 55 degree have same values which 21.55 meter per second. The distance of cannonball travel at angle 55 degree, a cannonball or object projectile will travel maximum distance on horizontal component. In conclusion, increasing the angle of launch will increase the vertical component of object travel but decrease the horizontal component object travel. Secondly, we will discuss effect of the initial speed of launch to its range. The range of the projectile is the displacement in the horizontal direction. There is no acceleration in this direction since gravity only acts vertically. In this experiment, the angle of launch and other factors are constant. The initial velocity can be divided into horizontal component and vertical component. Horizontal velocity Vx equal v cos theta, vertical velocity Vy equal v sin theta. From this experiment, the angle of project is fixed to 45 degree while gravity is fixed to 9.81 meter second squared. The range of object travel when initial speed are set to 10 meter per second, 11 meter per second, 12 meter per second, 30 meter per second, and 14 per second is 10.19 meter, 12.33 meter, 14.68 meter, 17.23 meter, and 19.98 meter. When launched, a projectile acquires a distinctly different horizontal and vertical velocity. During its flight through the air, the horizontal speed of projectile remains constant, but the vertical speed changes due to gravity. The horizontal distance depends on two factors: the horizontal speed Vx and the time. The initial speed of object is directly proportional to range of object travel.
From this experiment, we can conclude that at the angle of 45 degree produce the maximum range of distance travel, while the higher initial speed produce higher distance travel.